Good afternoon, learners. I'm sure some of you are surprised that you are seeing mathematics instead of biology. For the biology teacher, will be coming on Thursday. She has some bereavement at home, so she has failed to manage to come today. But nevertheless, we have to continue. So today you are going to have mathematics instead of biology. So biology, remember, on Thursday where you're supposed to have mathematics, you are going to have biology. Okay, welcome back. This is the GMF School Online, comprises Fountain Gate, Goka, and Mubuyo. Remember, if you want to take your children to one of these schools, do not hesitate. You can just call us. We enroll your child. Okay, so as for grade 12 class, we have embarked on a revision. We started with some topics actually from last week. The other week we revised some of the questions, but we'll continue revising, and this is paper 2. And under paper 2, we have looked at different questions so far, and last time when we met, we looked at how to find, to solve questions under geometric progression. Okay, now under geometric progression, most of the time it comes in section B, and the first part is either earth geometry or mensuration. So we have just decided to say, okay, after earth geometry, we have to discuss it today, mensuration. Okay, so this is one of the major topics that usually come in mathematics paper 2, and it has got 6 marks. Okay, so make sure that you should be able to solve it correctly. Do not even hesitate or start wondering how we are going to solve it. I've brought 2 questions here from different year. Okay, the other one is conic frustum, and the other one is pyramid frustum. So we wanted to see how we can solve such kind of question if we have been given either in this form or in another form there. Okay, so we shall start with the one that came in 2017. Okay, this is November, October. In 2017, the question came like this. Okay, the figure below is a frustum of a cone. So meaning that it's a conic frustum here. The base diameter and top diameter are 42 centimeters and 14 centimeters respectively. So we have here the diameter, the bottom part is 42 centimeters, and the diameter, the top part here is 14 centimeters. Okay, while the height is 20 centimeters. So meaning that the height of the frustum here is 20 centimeters, and we have to take pi equal to 3.142. So once we have been given a question like this, how are you going to solve it? How are you going to tackle such kind of question? Okay, now I know that to some of us it might be very difficult to solve a frustum, but if you know the formula of a cone, okay, volume of a cone, it will be very easy for you to find the volume of this frustum. Okay, now the volume for a cone, we know it to say volume is equal to 1/3, okay, by r squared h. So this is the volume for a cone. Now, if this cone has been cut, you have a cone like this one here. Okay? So the full of this cone is this one here. Now, if this cone here has been cut here, once this cone here has been cut, how are you going to solve it? Okay? If it has been cut here, they have removed the upper part here, meaning that you are remaining with this part, and this part is what we call a frustum. Okay? Now, the whole of this, the volume of the whole of this cone is 1/3 by r squared times h. So h is the perpendicular height of this cone here. Okay? The perpendicular height is h, not the slant height. Okay? Now, when you look at this part here, we have got 2 cones now that we have been given. We have this bigger one and the smaller one here. Okay, now for us to find the volume of this frustum here, we have to know the volume of the whole of this cone minus the volume of this smaller cone here. Okay, now the volume of this bigger cone is this one. We have even put here radius as our capital letter R and H as our capital letter H here, which is height. Okay, so for us to know this frustum here, the volume of this frustum here, we have to find the volume of the whole of this frustum minus the volume of the smaller frustum here. Okay, so now how are I going to do it? So this is the volume of the whole of this cone here minus 1/3 pi r squared h. Okay, so here the way it is here, it will be very easy for us now to come up with the formula. Okay, so we have common r here, we have pi here, we have pi here. So we have volume is equal 1/3 pi. We have factorized it here, meaning that we have taken the common factor. Okay, so once you take pi here and you take 1/3 here, what I'm remaining with is r squared h. R squared h minus, here we have taken out this one. What are we remaining with? We are remaining with this part here, which is r squared h. Therefore, this is the formula that we are going to use to find the volume of this frustum. Are we together there? Okay, now, before we calculate the volume of this frustum here, the first thing is to know the volume of the smaller part. But in this case, do we have it? We do not have. But we can create an imaginary one here. Coming like this, let me use different marker. We can draw something like this. So we have another frustum here, or another cone. Okay, now the way it is here, we do not know the height of this cone here. Okay, and this is our formula here. And this height here, the only height that we have is for the frustum. Meaning that for us to find the height of the bigger cone, the height of the bigger cone there, we'll say 20 plus h, smaller height. Okay? Are we together there? So the first thing is to find this h here, the smaller height, and the bigger height. So how are we going to find these two? We have to come back to similarities and congruence. Okay? Now similarities and congruence. How are we going to find? We have to look at the similar side. Okay? So we shall take it now. We know that our bigger height is 20 plus h, smaller h, while our smaller height is small letter h. So how are we going to find it? Because we have first to create that part. So we shall say it height, which is smaller, over the radius of this one here. So we know that the diameter here, radius is, the diameter is 14. Meaning that the radius is half of 14, which is 7. So we shall have here 7 equals. Then the height of the bigger cone, which is what? 20 plus h. 20 plus h over the radius of the bigger cone. So we have been given diameter, which is 42. What is the radius? The radius is half of this 42, which is 21. So what we are going to calculate here is the what? The smaller height. the height from here to here. Then we cross multiply like this. H times 21 is 21 H equals 7, which is 7 times 20 plus H. Okay? So what? 21H is equal to 7 times 20. What did you get there? You can even get your calculator. Okay? Seven times 20, 140. Plus 7 times H, because you have to multiply 7 by everything here. So 7 times H, we get 7H. Okay, then we put the like term together, which is 21H minus 7H is equal to 140. Okay, so what is 21 minus 7H? 21 minus 7H, we get 14. H equals 140. You divide here by 14, here by 14. H here, 14 into 140, we get 10 centimeters. So what we have found here is the smaller h. Therefore, the bigger h, we know that h here is equal to 20 plus the smaller h, which is 10. Therefore, 20 plus 10, we get 30 centimeters. Now, since we have the smaller h and the bigger h, meaning that we have got the full data now for us to calculate the volume of this frustum here. This is the conic frustum. Okay. So we shall solve it from here. We have our formula here, which is V is equal to 1/3 pi r squared h minus r squared h. Okay. So we shall substitute 1/3 times pi. Here we have been given here. Pi is 3.142 times radius here, the bigger radius. Okay, where is our bigger radius? Which is half of this, which is 21 squared, times h, which is 30, minus, we have radius here, half of 14, 7 squared, times h here, we have this h here, which is 10. Then you simplify. You can even get your calculator now. Okay? V is equal to 1 times 3.142 is 3.142 over 3 times. Okay? Remove this one. 21 squared. So you go to your calculator. 21 squared. Get 441. 441 times 30 minus 7 squared, we get 49 times 10. Okay, so V here, which is volume, we have 3.142 over 3. 441 times 30 times 30, we get 13,230. 13,230 minus 49 times 10, which is 490. So we have to start first with the one which is in the brackets. So after simplifying here, then we shall multiply by this part here. So volume is equal to 3.142 over 3. You subtract 13,230 minus 40. Minus 490. Okay. What did we get? 12,740 times 12,740. 740. Okay. From here, you multiply 3.142 over 3 times 12,740. What did we get? 12,740. So we shall have 13,343. 13,343 points. Okay? Point 0266. 02667. Okay. So we have not been told to leave the answer into a certain number of decimal places or certain number of significant figures. So if you have not been given the how you are going to leave your answer in either in a certain number of decimal places, you have to leave your answers in 3 significant figures. Okay. So how are you going to leave it? So count 1, 2, 3. You check the number here. Okay, this number is less than 5. So since it is less than 5, you add 0 to this number. Okay, but if it is 5 and above, you get 1 and add it to this number here. So it's less than 5. So we are going to have like this, centimeter cube. Why centimeter cube? Because we are calculating the volume. Okay? So this is how you are supposed to calculate the volume if you have been given a conic frustum like this one. Okay? And why have we changed here? Because here we have been given diameter, and why are we getting radius? Because in our formula there is radius. So it's very, very important that we need also to change this one to radius. Okay, you know the relationship between radius and the diameter. Radius is half of a diameter. Okay, that's why we have changed this one to radius. Okay, so do not forget, whenever you are finding this or you are solving such kind of problem, make sure that you have to find the height of the smaller cone, okay, and the height of the bigger cone before it has been cut. Are we together there? So this is the question that came in 2017, November. So I've brought 2 questions. The other one we said is a conic frustum, and the other one here is a pyramid frustum. So after solving the conic frustum, let's see how we are going to solve the what? The pyramid frustum. Okay. So for the pyramid frustum here, I'll wrap the other part here. Okay. Okay. So here I've gotten the question from GCE 2018. Remember, I'm just getting questions randomly. You can also go through these past papers. You find a question either in this form or in the other form here. So do not get worried. They might change it. Okay. So let's see this question here. The diagram below shows a beam in the form of a frustum with square base ends of sides 4 centimeters and 10 centimeters respectively. Meaning that we have been given here, this base here is a square base. And this here again is also a square top base. Okay. Now, the height of this beam here is 9 centimeters. How are we going to calculate the volume of this plaster? Okay? So, again, we know the formula of finding the what? The pyramid, the volume of a pyramid. Okay? Whenever you are calculating the volume of anything, remember it's the area of the base times the perpendicular height. Okay? So that's the formula that you are using to calculate any volume. The area of the base times the perpendicular height of that object. Okay, now let's see this one because it has been cut also. Meaning that it has to be completed. So, when you look at this part here, meaning that it continued like this. When you look at this, okay, before it has been cut here, you have the what? The pyramid. Okay? Now we'll take this part here as our base. And this is the perpendicular height. Okay? Perpendicular height. Now what is the formula that you can use when calculating the what? The volume of a pyramid. So volume of any pyramid is equal to 1 over 3. Now, here it is a pyramid. Okay, it is not now a cone. Because a cone has got a circle down. That's why for you to find the area of a circle, you have to use what? Pi, okay, r squared. But now here, it's a pyramid. Now, how am I going to find a pyramid? Okay, so we have L times H. So it's L squared. Why have we said L squared? Because it's a square pyramid. Okay, if this base here, if this base here is a rectangle, then we'll say L times B. But since it is a what? A square. So we can just say L squared. Whenever you're calculating the area of a square, it's L squared or S squared, meaning that side squared. Okay. Now, again, we have two here. The bigger pyramid and the smaller one. So for you to find the part here which is remaining after cutting out the smaller one, you have to subtract. Okay? So you are going to subtract minus L squared H. Then you are going to have L is equal, what is the common factor here? Remember this is capital letter L. So do not say that you have the common factor L squared, L squared. This is a small letter L. Okay, so you have 1/3 here. So 1/3. What are remaining here? L squared H. Minus, what are remaining here? L squared H. Okay, mind you, this is a what? A square base. Okay? Now, do we have H? We do not have. Do we have this bigger H? We do not have. We need to find them. Okay? So how are we going to find them? We go back to the similarities and the congruence. Okay? So how are we going to do it? So we can say, okay, now let's take it H, which is this one here, from here up to here. Okay? That is our H. Then, this smaller one here, if you want to find the smaller one here, what are you going to say? You say H minus 9. Once you get H here, minus 9, what you are remaining with is the smaller one. So we say over H minus 9 is equal to start with the bigger base here. The base here is 10 over the base of the smaller pyramid is 4. Okay? Then you do your calculation. H times 4, we get 4H is equal to 10 times H minus 9. Then you have 4H is equal 10 times H, you have 10H minus 10 times 9, we get 90. Okay? You put the like term together. Let this one come this side, this one come this side. So you are going to have 90 is equal to 10H minus 4, this is capital letter H. So what is 90 here equals 10 minus H, we get 6H. Then you divide here by 6 here, okay, by 6. So this one you cut here like this, so you cancel like that, you are remaining with H. Then 6 into 90, you get your calculator, 90 divide by 6. What do we get there? 15. Okay, now what we have calculated is the height of the bigger pyramid. Okay, now how are we going to find the smaller pyramid? We say that in order to find this pyramid here, the smaller pyramid, we have to subtract the bigger pyramid minus the height of the first term. Okay? So we have it here. The bigger pyramid, we have found 15. Minus the height of the what? The first term there is 9. So 15 minus this one, therefore H is equal to 6 centimeters. So we have all the data now that we can use for us to calculate the what? The volume of this first term here. Okay? Because we have the bigger height is 15, then the smaller height is 6 centimeters. Okay? And we have the size of the bigger base and the size of the smaller base. Are we together there? Now, once we are done like that, because we have this part, in other question, they might even ask you, find the height of the smaller pyramid. Okay? You have to do it like the way we have done it here. But in some questions, just ask you, find the volume of this first term. So, first thing you have to do is to find the what? The height of the smaller pyramid. Okay? So, let's go. Our formula says V is equal to 1/3 L squared H minus L squared H. So substitute it. We have volume is equal to 1/3 L squared, meaning that the base of the bigger pyramid, which is 10. So 10 squared times height, we have found here 15, minus L squared there, the smaller one, which is 4, squared times height of the smaller pyramid is what? We have found here 6. Therefore, volume, you simplify from here. 10 squared, we get 100. 100 times 15, we get 1,500. Minus 4 squared, we get 16. Okay? 16 times 6, what do we get? 90, I'm sure it's 96. So 16 times 6. 96. Okay. Then we start with the one which is in the bracket first, or you can distribute if you can. But to make life easy, we can start first by simplifying what is inside here. So volume is equal 1/3 1500 minus 96. We are going to get sure, because here it will be 10. 10 minus 6 is 4. You are remaining with 9 here. 9 minus 9 is 0. Here you are remaining with 4. 4, which is 4, and 1 here. Okay? Then our volume is equal to, you get your calculator, 1 divided by 3 times 1404. What do we get? Okay, so we get 468. 468 centimeter cube. Do not forget to put the correct unit here. If it's meter there, then it will be meters cube. Okay. So this is how you are supposed to solve any question once you have been given to calculate any volume for a frustum. It's either a conic frustum or a pyramid frustum. Okay, so they can give you in any of these form and you'll be able to solve. Remember the difference between a conic frustum and a pyramid frustum is the pi. Okay? Under pyramid frustum, we do not have pi. But conic frustum, we have got pi. Why? Because the area of the base, you have to use pi because it's pi r squared. Then here, for a pyramid, it's either a square pyramid or they will give you what we call a rectangular pyramid. So for a rectangular pyramid, what we are going to do, again, is the same. The difference here is that under L squared here, you are going to have L squared. But for rectangular pyramid, you are going to have L times B. Because for you to calculate the area of a what? A rectangle is L times B. So that is the difference if you have been given a question under rectangular pyramid. Okay? I remember one of the past papers, they brought a question that you are supposed to calculate the frustum of a rectangular pyramid. So that question, please, you can find it. I saw it in one of the past papers, I think 2018 November. So if you can go in 2018 October, November, you are going to find such kind of question. So it's very, very important that you also need to know how to solve it. And if you have got a problem, please, you can still contact us. We shall help you. Okay? Since we are revising past papers, I'm not going to give you a specific question that you need to go through. But I will request you to go through these other past papers. You are going to find one question there which is like this. Apart from the question that came in 2019. Okay? In 2019, it was not about calculating the volume of a what? Of a frustum. Okay, but you have to know the basic of calculating the what? Actually the question that came is about calculating the sides and the angle. So it was simple, actually. But most of the time the question comes like this and it's section B. Okay? They combine together with the questions under eighth geometry. Again, apart from last year November, this question came in section A. So meaning that it was compulsory that you have to answer whether you like it or not. So it came in section A. But the total marks remain the same, 6 marks. So you are not supposed to miss such good marks. Because for you to get 6 points, at least you need to get these questions that have got more marks correctly. Then it will help you to get 1 in mathematics. It's the only subject actually, if not one of the subjects that you can get 1. If not even getting 1, but getting everything. As long as you have gotten the concept. Okay? So my key interest here is you to get the concept of how to solve these. Mathematics is a leakage on its own. Even for those that are writing next week, you can also get helped here. Okay, because you find a question similar to what we have discussed here. Even though that are writing in November, still more you are going to find a question similar to what we have discussed here. So we'll keep on revising. I know that for those who are writing GCE, this one will be our last meeting. But for those that are writing in November, we shall continue revising. Even next week, as we are going to meet on Thursday, we shall continue by at another topic. We want first to exhaust section B, then we'll go to section A. Done that, we are going to start 1. Okay, so that by the end of the year, you'll be able to answer any question that you will come across. But for today, we shall stop here. Do not forget, still more, you can enroll with us. You can contact us if you want physical. We don't know whether the schools we are going to open next month or the other month. But once we open, still more, you can enroll with us. Okay, Fountain Gate, the school is found in Chongwe. And we have another school which is in Siabonga, Mubuyu, and that one is only for girls. Okay, and we have another day school which is found in the center of Lusaka, which is Goka. Okay, just next to Movie TV, you will find us. Okay, we are there to help you, and we will continue delivering service to help our children. For today, we shall end here and see you next week on Thursday. My name is Teacher Chirwa. Thank you.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at algebraic expression. So during this session, I'll be with you, and today we're trying to look at the summary of current electricity. We're trying to look at the summary of current electricity, and I've prepared about 2 questions that we will look at today. We'll look at 2 questions under current electricity. And my first question that I have for you is, I've got the first question here. First question is the figure and the current resistor. Okay, this is our first question that I have for you. Question 1 today under current electricity. We're looking at the summary of. Okay, let's do this. Look at current electricity, and to be precise, we're looking at the summary. And my first question that I have for you today, look at the figure. The figure shows a circuit diagram. Circuit diagram. And this is my circuit diagram that I have. Circuit diagram. So this is a circuit diagram, and the first question here they're trying to find out, calculate the effective resistance of the circuit. Calculate the effective resistance of the circuit. So the first part of the question here is saying we try to calculate the effective resistance of the circuit, and according to this diagram, this is what I have said. The figure below shows a circuit diagram. This is a circuit diagram. We have the ammeter here, we have got the resistor here, and the resistors here. Of course, they are in parallel, and we have been told, because when a question is being asked to you learners, you must identify how the circuit is arranged. Is the circuit arranged in parallel or in series? And when it is arranged in series, what are we supposed to do? The resistors are arranged in series, what are we supposed to do? When resistors are arranged in parallel, what are we supposed to do? Oh, we did that. So in this case, I calculate the effective resistance of the circuit here, the effective resistance of the circuit. Now, when we're trying to find the effective resistance of this circuit, if you check here, we do have 1.6 here resistor. Then here we'll go to these. So meaning, what we're going to do, we're going to find the combined resistance of these 2 resistors that we have, plus these are in parallel, plus the resistor in series. So look at the combined resistance, which will be equal to combined resistance in parallel. And what do we have in parallel? We do have our 6 ohms and 4 ohms. resistors plus 1.6 plus 1.6 resistor in series. So this is what we have. So in order for us, we know that we're trying to find the effective resistor of the circuit here. We do have what we call the combined resistors. We do to combine resistors in parallel. What did we have in parallel? In parallel, we do have our 6 resistor and 4 resistor plus the 1.6 resistor that is in series. So in order to work out this, we are going to say, first let's try to work out of what we have here, the one that are in parallel here. Then, so whatever that we're going to work out, the one in parallel, in the end, they'll be in series. So in this case, we'll say there's a formula that I gave you to say 1 over R is equal to 1 over R1 plus 1 over R2. So what did we have? What is our R1? Our R1 here is 1, and it's 6 plus 1 over our R2, we can say 4. Okay, 1 over R over R. So you look for the common denominator in this case. I mean, the lowest common denominator. If you try to look for the lowest common denominator here, you end up getting about 12. We know that 6 into 12 is 2 multiplied by 1, you end up getting 2 plus 4 into 12 is about 3, then 3 multiplied by 1, you get 3. In the end, you get about 5 over 12. So we do have our 1 over R. We do have our 1 over R, then here 1 over R. Okay, we know we introduce a cross multiplication, meaning here it will be 5R is equal to 12. We divide by 5, we divide by 5. We know this will go, our R is equal to 5 into 12. If you try to punch on your calculator, you get 5 over 12. I mean, if you try to divide 12 into 5, you end up getting about 2.4 ohms. So you get about 2.4 ohms here. Okay, meaning if you try to find the effective, the combined resistance for these two, the 6 and 4 here, we end up getting 2.4. But we are not done with the question. The question that asks us to say, we're trying to calculate the effective resistance of the circuit, meaning there's this other one that is in series. Now, since this one's the effective, the combined resistance for this, so meaning this and this are now in series. And you know what it is? When resistors are in series, then you're supposed to combine them, meaning you add them. So in this case, the effective resistance, I'll just use this other part. I'll say resistance, then EF, meaning effective resistance. We do have our 2.4 plus, our 2.4 ohms plus our 1.6 ohms. So meaning if you try to add 2.4 plus 1.6, you end up getting about 4 ohms. So the 4 ohms that we have here, that is the effective resistance. Hope you have followed. The first thing you're supposed to do, you look for the combined resistance. And how do we find the combined resistance? First, we work out the combined resistance of these that are in parallel. Then later on, whatever that you're going to get the answer there. Now, they'll be in series. What are you supposed to do? You add whatever that you get the combined resistance here and this one here. You combine them, you add them. Then you end up getting that. Let's try to proceed and look at the, hope you have followed and hope you have copied. Hope you have copied. I'm sorry for that. So let's go to the second part of the question here. The second part, I'll still use the same diagram. So I'll just take note here. Let's try to take note. We know that our effective resistance, according to the question, the effective resistance that we found here, the effective resistance here that we have was about 4 ohms. We'll take note of this part here. Let me just try to wrap this apart. Let's try to move to the second part of the question. B said the current through the ammeter. The current through the ammeter. The B part here says you're trying to find the current. We calculate the current through the ammeter. So we're trying to calculate the current through the ammeter here. Remember, this is what we have here, the ammeter. Now, we're going to pick it from Ohm's law. From Ohm's law. From Ohm's law. From Ohm's law, we know that current is equal to voltage over resistance. Now, let's try to have our data here. We must ask ourselves, what is the voltage? According to this circuit, our voltage here, which is our potential difference, in other case, so our potential difference here that we have is about 6 volts. Then what is our resistance? The effective resistance that we found earlier on is 4 ohms. So let's try to substitute. We substitute, you end up getting 6 volts. I mean, if you substitute 6 divided by 4. So if you try to divide, 6 divided by 4, you end up getting about 1.5 amps. Please take note. You must be very careful when it comes indicating the units. So that is the current through the ammeter, meaning this is the current that will pass through the ammeter here. Okay, so that is the answer, 1.5 amps. Let's go to part C, which is the last part of this question. Part C said determine the potential difference across 1.6. Hope you have copied this part. I'll still use the same part. Let's try to move a step further. We'll use this other part here. So, according to C here, let's move to C. Determine the potential difference across 1.6 ohms. We're trying to find the potential difference across that is 1.6 ohms. Now, we are told we try to calculate the potential or try to determine the potential difference across 1.6 ohms here. This is what we have here. So we'll still pick it from Ohm's law. We know that Ohm's law is equal to, current is equal to voltage over resistance. Now we're trying to find the potential difference, which is the one that we're looking for here. So we're going to make the V the subject of formula. So our V is equal to IR. Okay, now we have, let's try to list down the data here. Now, what is our current? What is our current in this case? Remember, earlier on, we did work out trying to find the current, and the current that we found earlier on was 1.5 amps. So we use the 1.5 amps here, because that will be the current that will pass it through this 1.6 ohms. This is the current that will pass through the 1.6 ohms. This is the current that will pass through the 1.6 ohms. Then what is our resistance? Our resistance still, since we've been taught, so we try to determine the potential difference across 1.6 ohms here. So meaning we use the same 1.6. So if you try to substitute, it will 1.5 multiplied by 1.6. Learners out there, if you try to punch 1.5 multiplied by 1.6, you end up getting about 2.4 volts. 2.4 volts. Learners, emphasize once more that you have to be careful when you are dealing with the issue of units. You must know what are the units for current, what are the units for potential difference, what are the units for resistance. Please, you have to know, because without units, meaning the answer has no meaning. Let's try to proceed and look at my second and last part of the question that I've prepared for you this afternoon. Of course. And my second question here to say the circuit diagram the circuit diagram below shows a network of resistors, and this is my diagram. Of course, you expect current entering, which is 6 amps here. I've got 3 ohms here. We do have got our 3 ohms here. We also got our 6 ohms here. So, and this is question 2A, and Roman numeral 1 here. They ask you, what current flows in there? What current flows in the 6 resistor? What current flows through 6 resistor? What current flows through 6 resistor? Now, if you try to look at this diagram that I have for you here, you check that we do have a network of resistors, and if you look carefully, you notice that as a physics student, I expect you that you're supposed to identify to say these are arranged in a series. If you check, these resistors are arranged in series. Now, the question comes, what current flows in the 6 resistor here? Now, one thing that I need to explain in order for us to try to find what current flows through the 6 resistor. If you check here, the upper loop here, we do have an upper loop and the lower loop here. The upper loop here, we have got the 3 resistor here and the 6 resistor, and the 3 resistor here. If you try to find a combined resistance for these 2 that we have here, if you try to combine these 2 resistors that we have here, we end up getting 6 resistors. If we combine, meaning we try to find a combined resistance here, it would be 3 plus 3 ohms. We end up getting about 6 ohms. Now, what have you noticed? Okay, we do have the upper loop here, meaning the upper loop, the 6 resistor. Even here, the lower loop here, there's also 6 resistors here. Okay, so meaning, in order for us to find the current that flows 6 resistor, meaning the current that flows in 6 resistor is just the same as the current that flows in the upper loop here. Meaning, in order for us to find the current, meaning our current in this case, that current that flows across the 6 resistor here, it will be about 6 amps divided by 2, which we end up getting about 3 amps. Meaning the current that flows through the upper resistors, the upper loop, and the one that flows through the lower loop is the same. So meaning this is the answer that I have for you to say, meaning the current that flows through 6 resistor is 3 amps. Let's try to proceed and go to look at the second part of this question. The second part of this question that I have, of course, we do have what is the potential difference? What charge? what charge passes through, the 6 resistor for 3 seconds. What charge passes through the 6 resistor for 3 seconds? Now, here they're trying to find out about the issue of charge. But you know very sure that if you're trying to find charge, which is abbreviated as capital letter Q, we know that charge is equal to current multiplied by time. We know that charge is equal to current multiplied by time. So in this case, let's try to come up with our data here. Now, what is our current? Remember, we have been told here to say what charge passes through the 6 resistor for 3 seconds. So in this case, now, earlier on, we dealt with a question whereby we were asked to say, can you find the current that flows through 6 resistor? What did we get? We get about 3 amps. So meaning this is the current that we're going to use that, it flows through 6 resistor. So it will be our 3 amps here. Now, what time? Time we've been told is 3 seconds here. Then it's just a matter of substituting. We know that 3 multiplied by 3, we're going to get 9. What are the units for charge? We know that the units for charge is coulombs. So this is the expected answer. We know that those are the units for charge. It's 9 coulombs. So 9 coulombs is the expected answer for that. Let's go to Roman numeral 3 of this question here, saying, what is the potential difference now? What is the potential? What is the potential difference across the 6 resistor? So they're asking us what is the potential difference across the 6 resistor. What is the potential difference across the 6 resistor? What is the potential difference across the 6 resistor? So again, we know that if you try to work out potential difference from Ohm's law, try to work it out that one, you end up getting potential difference is equal to IR. From Ohm's law, we know that Ohm's law, I is equal to voltage over resistance. If you try to make the potential difference the subject form, you end up getting this one. So we have been told to try to find what is the potential difference across this 6 resistor. So we'll try to have our data here. Now what is our current? We know that our current in this case is about 3 amps. Remember, the current that flows through 6 resistors is about 3 amps. Even here, we combine them to be 3 amps. Then what is our resistance here? We've talked about 6. So you substitute, it will be 3 multiplied by 6. If you try to multiply 3 multiplied by 6, we end up getting 18 watts. We end up getting 18 volts. So that is our potential difference across the 6 resistor. That is our potential difference across 6 resistor. Let's try to look at part B of this question here. We do have got part B. Hope you have copied this part. We are still dealing with the question 2. Now look at part B. We're looking at part A, we'll look at part B. And my part B reads saying a 2 kilowatt, 250 volts electric fire is connected to 250 volt mains. A 2 kilowatt 250 volt electric fire is connected to 250 volt mains. And under this question, under this part B, a question that comes to say how much current does electric fire take? How much current does electric fire? How much current does electric fire take? That's my first part of B. How much current does electric fire take? Hope you have copied. Try to use this part now. So, according to B, say 2 kilowatt, 250 volt electric fire is connected to 250 volt mains. Yeah, 250 volt mains, yes. Then how much current does the electric fire take? How much current does the electric fire take? Now, we have been told to say here, a 2 kilowatt 250 volt electric fire is connected to 250 volt mains. How much electric current? How much current does electric fire take? So, in this case, we know that in order for us to try to find current, we have this formula: power is equal to IV, or power is equal to VI. Whichever route that you take, whether you start with the VI, but for me I'm comfortable with IV. So from that, we know. Now we try to make current the subject of the formula here, because we've been told how much current does electric fire take. So if you try to make the subject of the formula, we do have our current is equal to power over V. Now let's try to have our data here now. Now according to our data, what is power? Power, we do have 2 kilowatt. Now in this case, we're going to convert 2 kilowatt, we change to watts. Okay, meaning you have to multiply by 1,000. So if you try to multiply by 1,000, you end up getting 2,000 watts. So this is the power meantime. Then what is our voltage? Our voltage, we know, is about 250 volts. So then you substitute 2,000 divided by 250. If you try to work out that one, you try to punch on a calculator, what are you going to get? You get about 8 amps. You get about 8 amps. Meaning this is the current that the electric fire takes. And let's go to part 2, that is 2 of this question, where they're saying, and this seems to be the last part of this question here. And according to this, they're asking us to say, what is the cost of running? What is the cost of running? What is the cost of running? What's the cost? What is the cost of running? What is the cost of running electric fire for 5 hours? For 5 hours, if the cost of a unity, which is kilowatt hour, of electrical energy is 900 kwacha. So the question is saying, what is the cost of running the electric fire for 5 hours if the cost of a unity, and this unit is a kilowatt hour, of electrical energy is 900 kwacha. is 900 kwacha. Now, if we're trying to deal with this, we have to deal with the number of kilowatt in hours. I mean, kilowatt hours. We have to deal with the number of kilowatt hours in this case. First thing, in order for us to find the cost of running this electric fire that we have here. Okay, so under this we do have our solution for this. What is the cost of running the electric fire for 5 hours if the cost of a unit kilowatt hour in electrical energy is 900 kwacha? Now, so in this case, we're trying to find the energy here. First thing, we know that energy is equal to power multiplied by time. Okay, meaning this energy must be in kilowatt hour. So we know that energy is equal to power multiplied by time. We do have our data here. What is our power in this case of running this? What is the power for this? I mean the power that is used to run this electric fire. We know that the power that is used to run this electric fire is about 2 kilowatt. So it's 2 kilowatt. Now, how long does it take to run this electric fire? We're talking about time, and in this case we've been told 5 hours. So it's 5 hours. If you try to substitute, it will be 2 multiplied by 5. We end up getting about 10 kilowatt hour. It's 10 kilowatt hour. Okay, so now we are not done with the question. The question they're trying to ask us to say, what is the cost of running electric fire? So we're trying to find the cost of running electric fire. So cost of running electric fire. Cost of running electric fire. In this case, we're trying to find the cost. We're not done. Now, in order for us to try to find the cost of running this electric fire, we know that cost will be equal to what we have done here, the kilowatt hour, the energy that is used here, 10 kilowatt hour. 10 kilowatt hour. We'll just leave it the way it is, 10. Then multiply now the actual price. We've been told to say a unity is about 900 kwacha. A unit is about 900 kwacha. So multiply by 900, we end up getting kwacha. Boys and girls out there, meaning in order for this company or this house to run this electric fire for 5 hours, it will cost them 9,000 kwacha. You can imagine how expensive. Probably it's industrial electric fire, because in our houses we can't manage. That's just too much. So in order for them to run this, and I suspect to be an industrial electric fire, just for 5 hours, it will cost them 9,000 kwacha. Boys and girls, this is what I had prepared. We tackled about questions. I do have a question that you need to try out. Try it out. And I have a home task for you to say a 4 resistor DVD, 6 resistor shaving machine, and a 12 resistor radio cassette are connected at the same time. Parallel across 24 volt power supply. Draw a circuit diagram to represent this connection. And B, find the total resistance the circuit offered by all the three appliances. And my last part here is to calculate the current. Calculate the current in each appliance. Let me just go through once more. Hope you're copying this question. A 4 resistor DVD, 6 resistor shading machine, and a 12 resistor radio cassette are connected at the same time, parallel, across 12-volt power supply. Draw, the first part, draw a circuit diagram to represent this connection. B, find the total resistance in the circuit offered by all the three appliances. And last part, to calculate the current in each appliance. So learners, you are preparing for the exams, the grade 12, the GCE. You expect different questions. A question is either you can be given a diagram has been drawn already for you, then questions will follow up, you'll be able to answer. Or a question will come in this situation of which I know that we did this part. So in this case, you need to come up with a diagram and answer the questions that follow. So remember, when you make a mistake, meaning all the answers that follow are likely to be wrong. Always remember to mask up. COVID-19 is real. Thank you so much. You have been with me, Mr. Banda Ray Bells. Until next time.
Good afternoon, class. And these are examples of crops that we grow in Zambia and the livestock.
Look at the algebraic expression.